Okay, so I'm going to be honest on this last one that we're looking at. You're really going to have to make sure you follow along. You should have got a worksheet passed out to you that doesn't have this exact problem, but one very similar to it. Okay, that has all the steps written down. So you don't need to be writing anything down right now. You just need to follow along and sort of see what's happening. So we're basically going to put all the pieces now together that we know. So you're going to be completing some of these problems in Delta Math. Okay, you have 3 of them to complete. This example says a mathematics teacher wanted to see the correlation between test scores and homework. The homework grade is in the X, the test grade is in the Y, right? So when a student earns a certain grade on homework, what's the grade they get on the test? Okay, so that it says write the linear regression, which is going to be that we now, instead of just trying to guess at what the best fit line is, we're going to get Desmos. We're going to get a calculator to do it for us. Okay, so you don't need to know how to do all the work. We're going to get technology to do it for us. We're going to get it to actually tell us the best fit line, okay, without us just sort of guessing and eyeballing it. In this particular example, it tells us to round to the nearest tenth. So make sure you read. That's going to be important. And then we're going to use that so that we can make future predictions, right? That's our inferences piece that we talked about. Based on data that we know, what educated guesses can we make based off of the data? Okay, so my suggestion is that on your computer screen, you open 2 separate windows, okay? And you sort of make them both half of the size of the screen. Okay, so over here, I just went to desmos.com, which is your link on Canvas. Okay, and then just like we've done before, you're going to click on the graphing calculator and you'll get here. Okay. Actually, for the time being, I'm going to put this away so it's not in our way at all. Right, and you're going to have these 2 things. So the first thing that we want to do is we want to get all this data that we have entered into Desmos. So to do that, you're going to hit the plus sign right up here, and then you're going to select a table. And you're literally just going to copy it over. So my X column, I'm just going to start going straight down. Now you could go right to left. I think it's easier visually for me to just go straight down and to type these all in. And I'm going to do my other side. Um, 63, 79, 71. Okay, so all I've done now is enter this data. Okay, now these numbers over here are like in the 80s. Over here on my graph, I'm in like a 0 by 10 window. So I'm just changing my zoom because I actually want you to see what's happening here is it's plotting these points for me. Okay, so now I'm looking at what this scatter plot actually looks like. And what we see here is that we have a strong correlation, a strong positive correlation. Okay, but instead of us just clicking 2 dots and sort of guessing what the best fit line is, we're going to get Desmos to do that for us. So now we're going to click so our cursor goes in the box 2. And we are going to type in Y1, Y with that little subscript like we saw in point form. But if you just type Y and then 1, it makes it be Y1 for you. Then we want to use not an equal sign, but approximately sign because we don't know. So we're going to hit the tilde, which is to the left of your 1. You have to hit shift and then that key to the left of your 1. MX1. So again, when I hit that 1, it goes in plus B. So basically, I'm saying Y equals MX plus B, write the equation based off of this data. And all of these different numbers pop up down here. Okay, this R right here, not the R squared, but the R value, is our correlation coefficient. Okay, that correlation coefficient, remember we talked about in the video previously, not today, but in our causation versus correlation, has to be in between 1 and -1. The closer this is to 1 or -1, the stronger the correlation is. So the fact that this is a 0.9383 means that this is a strong positive correlation and those dots better be pretty close together, which they are. So that aligns with what we would assume. Okay, it's also going to spit out an M and a B value for us. Well, and B are what we need to write the equation of a line. So now I'm going to go into my third box here, and I'm going to type in y equals, and now instead of m, I'm going to put in the m value. Now, if I looked up here, this particular problem said round to the nearest 10th. Okay, so right here, round to the nearest 10th. So I'm going to round these coefficients to the nearest 10th. Now, read carefully. It's going to tell you something different every time. And frankly, that's a good skill for you all to be working on your rounding. Okay, so I'll have y equals mx. So my m rounds to 1.0 plus b. So b is negative 7.8. So what I'm doing is what we just did in our last unit. I'm giving you m, I'm giving you b, and you are writing the equation of a line. No different than when I said m is 4 and b is 15, and you plugged that in. Now we just have decimals that we're using instead. Now, we rounded it, so this might not fall exactly on top of it, but it falls really stinking close. Okay, this is going to be our equation that is our linear regression. It's our line of our best fit. So that's what's going over here. Now, this also wants to know, okay, what would our projected guess be for a student with a homework grade of 54? Now, there's two ways that we can use this equation. Okay, we have an equation that says y equals 1x minus 7.8. So we have y equals 1x minus 7.8. It wants us to find what the y value would be, right? What the test grade would be based on knowing a homework grade of 54. So one option is that we can plug in 54 for x, and we can do that by hand. So we can say 1 times 54 minus 7.8. So this goes back to our functions unit where we're plugging in x and y values. And then you could just pull out a calculator or whatever and do 54 times 1 minus 7.8, which gives us 46.2. Now, again, when we look over here, this says to round it to the nearest integer. So that's going to be our nearest whole value. So if I'm talking 46.2, that's going to round to 46. Okay, and so for my value down here, I'm going to put in 46. Okay, and that will tell you right or wrong. Now, there's another way that we could also look at this to check an x value. Okay, so this is just a trick you can use as long as it's the x. Over here where we typed in the equation, you can go up here to settings, and you can edit this list, and it will allow you to click on a table right here, and you can plug in the x value of 54, and it will just spit it out for you. The problem is that this doesn't work backwards, so I can't like type in something over here and go backwards. And the key here is that we might use this equation either way. So you can see a problem very similar to this that says, what would we predict was the student's homework grade if they scored an 87 on the test? Okay, and this is talking in reverse. So this says if they scored an 87 on the test, what would their homework grade be? And so we then know the y value. So we'll do a very similar idea. I forgot the equation, minus 7.8. So we'll take that same equation, y equals 1x minus 7.8, except now instead of plugging in for x, we would be plugging in for y. And so that means we need to go back to our solving equation rules. See how this is sort of why we've been doing all the other things this trimester, right? They are sort of all tied together here. So we'll get a 94.8 equals 1x. You could divide by 1, but we just get 94.8. So if we scored an 87 on the test, we could probably predict we would get a 94.8 or have scored a 94.8 on the homework. So you should be using the list that you should have passed out to you that has all those steps for you. Okay, at the end, I gave you the steps for how to turn it into a table, but you could decide to just do it by hand as well. Either way is fine. Okay, you're going to go into Delta Math and you're going to do a few of these on your own. Okay, this is definitely trickier. So I set it to 3. Do the best that you can. Make sure you read the instructions carefully. Okay, and get some practice with typing that information into Desmos and trying to get that best fit line.